ルイスの形でバージョン8におけるレプリケーション変更というところでご紹介させていただきたいと思います。
Am I audible? All right. So, welcome everyone to this session about MySQL replication. My name is Soares. I'm the MySQL replication software development director at Oracle. I've been doing MySQL replication for it's 10 years this year at MySQL at Oracle, and before Oracle at Sun. And today I'm here to talk to you about what's new in MySQL 8, what's new in replication in MySQL 8. Some people have asked me where I was from before, in the hallway and whatnot. I come from Portugal. It's a long way here, but I'm very happy to be here. It's my first time in Japan. I'm really enjoying it. I love the people. I love the city. Everything is very, structured, very organized, and the people and it's just very friendly, very welcoming, and the food is also very good. So thank you. Okay, let's talk about replication. This is the proposed agenda for this session. Talk a little bit about MySQL replication, what it is, how it has evolved over the years. Talk a little bit about how people use MySQL replication, what are the use cases, how people use it in production, how do they make the most out of it. Then talk about what have we been doing recently in MySQL 8 and also things in MySQL 5.7 because we backported a few features from 8.0 to 5.7 so that we evolve the product to help you make the most out of it, and by making the most out of it, enhancing your business. I'll also briefly mention a few things that we have in the labs. So these are things that are not yet released, but are things that we've been working on, and we put on a labs release out to get early feedback on these new features. I'll also talk a little bit about the roadmap, where we are, what we have done, and where we are heading. So what lies ahead in our strategy in terms of new features that we want to put out, and talk about the big picture of what we want to achieve with all these things that we're doing. And then, of course, conclude this session. So it's not a very big agenda, but the content is quite a lot. So I'll try to go a little bit fast. If you want more details about any of this that I'm talking about here, you can reach me by email or just grab me outside. So before I go into the specifics of MySQL replication, it's a fact. Let me just talk a little bit about the context. It's a fact of life that the web has exploded recently in terms of the amount of data that we have to move around, that we have to handle, that we have to manage, that we have to replicate. It's just a fact of life. And this is mostly motivated by the fact that we have a lot of social media out there, a lot of people posting their opinions either through Facebook or some other social network, Twitter, and so on. Also, there's a lot of distributed software components working together. It's not a stack anymore as it used to be, like the LAMP stack. Linux, Apache, MySQL, and PHP and Python. It's more of a set of technologies working together. It's a mesh of technologies working together. And this often means that we require much more advanced automation in our systems. So lots of data being moved around, lots of different systems and technologies working together makes or imposes requirements on the DBAs and on the operators to automate things further. Not only that, a lot of our users or a lot of you guys are thinking about moving things into the cloud, and moving things into the cloud often means that you want to be able to automatically scale out, control what services are up and down, and maybe sometimes you want the services up during this peak hour of the day because that's where you have more requests, for instance, more orders. And during the nighttime, you want to scale down the system by shutting down parts of the infrastructure because you don't want to pay as much in terms of computing and energy and storage and so on. So, in addition to that, we see things like the Internet of Things coming up, where we have a lot of many data producers out there, sensors, even domestic appliances generating data that we have to ingest and store somewhere for, to later do some kind of analytics, for instance. All this is, we're talking about a very different scale nowadays than what it used to be 10 or 15 years ago. And MySQL itself is very popular. It's where, on top of MySQL, the web came to be. It was, based on MySQL because one of the reasons was because, or one of the popular reasons was because MySQL has had replication almost from the beginning. So to be able to continue to be relevant in this space, we need replication to keep up with all these different requirements that we have today. So replication itself is very simple. We execute something on the server, and then this execution generates some changes to the data, and then we replicate these changes to some other server that will ingest these changes somehow and make the other server to become similar, or a mirror of the other one, if you will. It's very simple, but the devil is in the details. So there's a lot of things that we have to think about when we are deploying and implementing such systems. And in particular, in MySQL replication, the architecture of MySQL replication, from the bird's eye view, it's also very simple. We have one server, we have a log that is shipped around, we call it the bin log. The bin log is kind of a change data capture log where we write to the changes or the statements that cause the change in the server, and then this log is shipped around through a communication framework to some other servers, which we call the slaves. And the slaves will take this log, will apply this log, and will bring their state up to date with respect to the master, which is the server where the original execution took place. Up until 5.7, the communication framework was quite simple in the sense that it was, with asynchronous replication, we have one master, and then between the master and the slave, there's a TCP connection on top of which the MySQL protocol is used to transfer the bin log between one master and one slave. And comes 5.7, we introduce this new replication plugin, which lies at the core of InnoDB cluster. We call it the group replication plugin. And the group replication plugin enhances this communication framework by implementing services at this level. Things like membership management, failure detection, total order delivery, all these things are built on this communication framework, and then act as a basis to build some more advanced replication strategies on top of that. Since we have these nice guarantees like membership, failure detection, total order delivery, we can actually build some very resilient replicated state machines. So this slide is pretty much what I said. With some details, just the communication framework. As I said, it has these nice properties of failure detection and so on. So some more things go on between the servers in the group when compared to traditional asynchronous replication. And the rest, it's pretty much self-explanatory. And I think most of you, actually, who here uses MySQL replication? Can we do a show of hands? Okay, so a lot of people uses MySQL replication. Thank you, thank you. So you already know most of this. So let's move on. Just a quick word about the bin log. The bin log, or the binary log, is a logical log. And just as MySQL replication was very popular, or it was one of the reasons why MySQL became very popular from the get-go, the bin log today, or the binary log today, is also a very, very popular and important part of MySQL, as it acts as an integration tool to integrate MySQL with other systems. Remember when I mentioned at the beginning of this session that it's not a LAMP stack anymore, it's many different technologies working together. It's very typical, very, it happens many times that when I talk to people, they say, I have a MySQL server, I have the bin log, and then I have regular replication going on, but I also use the bin log to integrate, to publish these changes to some other consumers by copying the bin log to some Kafka stream, and then downstream consumers will react to this bin log, which are not MySQL servers, are some other servers, but can easily parse the bin log because it's a logical log. So the bin log is a very, very interesting, it is becoming more and more a very interesting integration component of MySQL nowadays. And also, I would like to just draw some attention to this. Since 3.23, MySQL 3.23, we had replication, asynchronous replication, only statement-based replication. And then in 5.1, row-based replication was introduced, still asynchronous. And in 5.5, we introduced semi-synchronous replication, meaning a master replicates changes to the slave and waits for the slave to acknowledge back before the master acknowledges to the application that the transaction has committed. So you have kind of like an additional guarantee that the change is stored redundantly, at least in 2 servers. And then in 5.7.17, or since 5.7.17 and 8.01, we have group replication with this, it's much more of a clustered kind of replication system for high availability with all these nifty features like automatic failure detection, membership management, atomic multicast, and so on. So use cases. This is one of the things that we want to do. Clustering made practical, easy to manage, easy to deploy, easy to set up, easy to keep it going, basically. And why do we want to make clustering made practical? Because we want to be able to replicate seamlessly. We want to be able to, automate it we want this clustering framework to be as automated as possible, so that instead of you guys as DBAs or operators spending your time nurturing MySQL servers, you can spend time with your kids having fun outside, maybe playing some soccer or something like that. We also want to build this story about being able to integrate more easily the MySQL server with other technologies, so playing along with all the new kids on the block and so on. And also to be able to scale it both in terms of reads and writes. And at the end of the day, we just want to enhance the entire product, the entire offering in terms of high availability and resilience, so dependability of the MySQL server. So a lot of people use group replication, for instance. Actually, one thing that I should state up front is we released group replication roughly 1 year and a few months ago, like 4 or 5 months ago, and it's probably one of the fastest adopted products that I've seen at MySQL. We have a lot of people that uses it with a single primary configuration where you have a cluster or a group of servers working together, and then you have a primary that takes changes, and then you have a bunch of secondaries. But the fact is that you can also deploy it in this way, where you write to different servers, and there will be some conflict detection, provided that you follow some rules. There are some limitations, but this is well explained in the manual. But it's at its core, we're building, continue to leverage or continue to build, enhance this replication story at MySQL, where group replication plays a very central role. We want to continue to build on the automation side as well. Group replication helps quite a lot in the sense that since we have these nice guarantees, we're talking about the distributed system here, right? So all these servers are working together, and when we have a distributed system where all the servers work together and they have to cooperate and coordinate themselves automatically to achieve something, we are eventually talking about things like distributed agreement between servers, consensus, and then all of a sudden we're talking about things like Paxos and Raft. I'm pretty sure that at least some of you have heard about these distributed coordination algorithms. And these distributed coordination algorithms allow for things like automatic failovers with automatic primary elections without the DBA having to do anything, as long as the group of servers that is acting together can alone take decisions. And for that, it usually means that the quorum between the servers has to be reached. So at the core of group replication, there's this Paxos implementation, and then on top of it, we build all these new nice automation things like, who are the secondaries. Every server realizes who are the secondaries automatically and consistently, and then who is the primary, and all the servers say, automatically and consistently they decide who the primary is without having to require external tooling to operate in the system. And once this is done, it also means that the system itself has protection, automatic protection against things like split brain, because it's the group that actually works together to achieve something. If it's unable to achieve something, it will delegate its responsibility to the DBA for it to go in and resolve things. But as long as the group is set up in a way that, if you want to tolerate one failure, you need 3 servers, so that at least you get a quorum of 2. If you want to tolerate 2 failures, you need 5 servers, so that at least you have a quorum 3 out of 5. And once you get the quorum, the group will be able to automatically react and fix things that are going on. So a lot of this automation is built into it. It's possible because of this framework of group replication. As I said, the bin log, we continuously improve the bin log. The bin log is a tool or a component that is used to capture the changes from the server and integrate them into some other systems. We see a lot of these things happening. Like the bin log is mined, transformed, and then loaded into some other systems like Hadoop, Kafka, Solar, Lucene for better indexing and text searching and so on and so forth, or just to feed downstream consumers that are not exactly MySQL servers, as maybe it's some cache system that needs to be invalidated and so on. So this is one thing that we continuously work on. So enhance the contents of the bin log so that it's not just used in MySQL replication, but also in other use cases. And we want all of these different technologies to work together to do things like read, scale out, but also DR, as in disaster recovery between data centers by deploying one group in one data center, or one cluster in one data center, another cluster in another data center, and then connecting both with asynchronous replication. So you can mix and match the different kinds of replication that we have in MySQL, to be able to achieve these kind of things. And at the end of the day, we want to continue to execute on this, on the roadmap we have to provide this InnoDB cluster, which is an integrated solution of clustering, the clustering features with a MySQL shell that is able to also automate a lot of the configuration and management of the cluster itself. And we have the MySQL router to interface the cluster, to act as an interface to the cluster from the application standpoint, so that the application doesn't notice things like failovers that are happening inside the cluster. So things are much more transparent to the application, because the router will take care of that. The router will take care of which server are we writing to, which servers are in the group, and then the application doesn't have to know any of this. The entry point to the cluster is then the MySQL router, which is aware of everything that's happening here, and doesn't bubble up this information to the application, so the application doesn't have to deal with it. So let's talk a little bit about how we're enhancing the product to actually drive it towards meeting all these requirements, or at least, or even not just meeting them, but go one step beyond. So in MySQL 8, we continue to execute on the bin log, binary log metadata information that is stored into it, so that we make it easy for people to use the bin log as an integration point, as an integration or as a capture data change framework to integrate data into some other systems as well. And we added things like transaction length into the GTID log event, emits timestamp. So this is not just useful for integrating data into integrating the bin logs into some other systems, but it's also, as you will see, it also allows us to implement some other features in terms of observability. And this is especially related to the commit timestamp, so I'll go into that later on. We also continue to improve the row-based replication infrastructure by adding more metadata about tables, things like what are the types of the columns, which is the primary key of the column, which is the sign of this numeric column, which is the character set, and so on, which are the column names for this table. And this goes into the table metadata in row-based replication, so that if if you're mining the bin log and you need to figure out or use this information, you can. It's there, and it's easier to integrate into some other systems. We had a few customers requesting this, so it seems very interesting for a lot of people. On the operation side, we added multi-source replication in 5.7, and which was really great. People really enjoy this because it helps to build these more advanced workflows where we where you want to consolidate data from multiple MySQL servers into a single one. Maybe you want to do complex queries across on data that is spread across different MySQL servers, and by using multi-source you can consolidate this data into a single server, and then it's easier for you to build your queries. But one of the things that people asked for immediately after they started using multi-source replication was, man, it would really even help us further if we had a way to install filters per channel. So in MySQL 8 we deliver this feature where you can specify per different source or per source which kind of data you're interested in, so you can filter the data that is coming in based on the source that you're connected to, as opposed to setting up filters for setting up global filters that operate on all channels as well. So we also continue to improve group replication, and in this case we added a feature where if you're running group replication and some server for whatever reason is kicked out of the group, it will automatically set itself to super read-only. And in addition to that, what we did was also, if you stop if you stop group replication on this server, on a specific server, it gets disconnected from the group, and it will also automatically set itself to super read-only to prevent involuntary changes to the server. Maybe you're just doing maintenance on this server, so you take it out of the group for a while, and while doing so, you might inject a transaction that's not supposed to go into the group, but then if you log it into the bin log, then you try to join to the group and you can't, because this is not part of the this server is diverse from the rest of the group. So this is the kind of situation that this prevents. All right. Also, we added a feature to provide election weights, in the sense that if you have a group where, in this case, we have a group with 3 servers here, A, B, and C, and B is the primary, so it's the server that we write to, the other 2 are secondaries, then they are read-only. If we take B outside of the group, the group has 2 members, so it will realize that the primary is gone away, so it will have to elect a new primary. And by using the weights, we can influence the selection by saying the guy with the highest weight, the server with the highest weight, if the current primary goes away, the guy with the highest weight will be the next primary. So this guy will win the election. Before this feature, choosing which was the next primary was kind of random. It was actually based on their UIDs, but with this feature is much more clear how to influence which will be the next primary in case the current primary goes away. This is much easier, then it becomes much easier to operate a group. For instance, maybe you want A to be the last guy to be picked as the primary because it has, maybe it's a smaller instance in terms of hardware profile, and C is much more appropriate, or maybe it's A is in a different network segment than that of C. So this is one easier way for us to influence the primary election. So this feature, if I'm not mistaken, because I can't read Japanese yet, This feature is about enhancing the flow control in group replication. So what is depicted here is that A and B are running fine, A and C are running fine, and B is for whatever reason lagging a little bit behind. So A and B will kind of throttle themselves to give B a chance to catch up, and so that its lag doesn't fall behind a certain metric. And this is all fine and good, and it exists already in 5.7. What we did in 8.0 is to provide more configuration. Okay, thank you. So I'll go quick now. So we only have 10 minutes, so I'll go quick. So what we did in 8.0 was to provide more configuration options to be able to tweak the flow control mechanism, whether setting up different quotas for A and B and C, setting up different flow control criteria and so on. So this was not in 5.7, but it exists now in MySQL 8. So monitoring, we also extended monitoring. Remember the commit timestamps I mentioned earlier that we put in the bin log? These commit timestamps also allow for us to have a much better alternative to the often broken seconds behind master feature. So now you can much more accurately realize how far behind in time one server is with respect to its master. But in addition to that, you can figure out how much far behind, for instance, this server is with respect to the server where the original execution took place. So you can measure seconds behind your immediate master and seconds behind the master that executed the transaction in the first place, which is this and this. So this is all in performance schema now, and in addition to that, we can measure the during the different stages of the slave that the slave goes through before it commits its transaction. We can also measure how much time a transaction spends on the different stages. So how much time it's spent in the relay log, how much time it's spent being applied by the slave, at which point in time it was received from the network, and so on. So we can look at the applier pipeline and figure out how much time it takes for a transaction to traverse it. So from the moment it is received until the moment it is committed on the slave. And in the group application as well, we added more information to performance schema to just go into some server and select from that server and get statistics from all the different servers in the group. For instance, if I connect to A, I can ask A, what's your role, and what are the roles of the other servers, and what are the versions of the other servers in the group, and so on and so forth, instead of going to all the different servers and asking for this information. We also, performance is obviously also, performance and efficiency is always a very big topic at MySQL. Coming back to what I mentioned at the beginning, lots of data to move around, lots of people today, they don't, if they wait 2, 3, 4, 5 seconds, it doesn't really matter anymore. They just move on to the next thing, right? So as long as we keep handling the data and moving the data around fast, we are meeting the requirements of the web services that people provide out there. And in MySQL 8, we introduced this this right-set-based parallelization. So it's a much more efficient way to track dependencies between transactions, and then using this dependency tracking mechanism, being able to apply more transactions in parallel on the slave. It's somewhat simple to explain this, the dependency tracking mechanism, because it's ultimately, it's basically something like this. If any two transactions change different rows, they can be applied in parallel on the slave. So if we have, transactions in the relay log that touch different parts of the data, we just take them and apply them in parallel. This results in being very, very quick at a low thread count, and in particular, the slave is able to apply a single-threaded workload on the master in parallel. And so that's why you see, in this case, that this big column here, or big transaction throughput here, on a single-threaded workload on the slave side, because it just took the entire batch of transactions and applied it in parallel, even though it was a single-threaded workload. This is pretty much what I said. And the side effect of this is that it also helps the group replication recovery procedure, because when the server joins the group, what it does is a point-in-time recovery from the bin log of some other server in the group. And this is the same thing. We take the bin log, we ship it to the recovering server, we apply as many transactions in parallel as we can, and then recovery takes far less time than applying it then sequentially or through some other parallelization mechanism. And as you can see here, when the system is running at 33% of its capacity, and we are using sysbench read-write with and without write set, we can see this difference in ratio for the time it takes to catch up when we use write sets, which is the orange bar, versus when we don't use write sets. The same thing here, but at 66% of the capacity. So when the system is processing enough transactions that it's at 66% of its capacity used. We also did improve the applier pipeline so that we have less contention between receiver threads or IO threads and SQL threads. So they used to contend for a lock that protected the positions of the position that I'm writing to as IO thread and the position I'm reading from as SQL thread. So this was causing some contention, and we removed a bit of those bottlenecks. And this means that we, again, have higher throughput in MySQL 8 on the applier side, on the slave side. Also, another interesting feature. Fred was talking about a little bit about the doc store before me, and a lot of the doc store story is about JSON, being able to utilize the JSON data type for many different purposes. And we enhanced row-based replication to be able to replicate just the diff of the JSON object that you're changing, instead of shipping the entire, let's say, the entire JSON document in the row-based replication images. So this, of course, obviously brings a lot of benefits in terms of the amount of memory that the amount of bytes that we store in the bin log. It also brings a lot of benefits in terms of the amount of memory that we keep, the amount of bytes that we keep in memory for handling the bin log. So the IO thread has less bytes to write, the SQL thread has less bytes to read, there's less bytes to move around, so the system becomes much more efficient as well. So this is the partial JSON replication feature that we have in the row. This is just some charts showing the performance of this. Incidentally, this feature, or the fact that we replicate partial JSON also improves performance on the applier side at the cost of some performance reduction on the master side to be able to strip to get the diff out of the JSON object. And there's a bunch of other replication features, smaller on paper, because some of these actually took a lot of sweat, blood, and a few tears. So, but work was really fun while during the development cycle of MySQL and MySQL8. And in addition to that, we have backported a few of those replication features into 5.7. Honorable mention to this. Yeah, my Japanese is a little bit rusty, but if this is the right set, we backported it to 5.7.21. I don't think it is. Okay, so we backported the right set patch to 5.7.22, and these other patches that are, or these other things that are marked as backported into these other versions. So in the labs, we have some features to make, for instance, I mentioned the feature earlier about when the server is kicked out of the group or you stop it, it sets itself to super read-only. Some people actually want the server to be shot in the head instead. So if it happens to fall outside of the group involuntarily, what happens here is that the server will automatically abort and shuts itself down because it's run into some critical condition and it's unable to continue. So you can control this action with this system variable, the behavior with this variable. This is on labs. And also monitoring, we instrumented more of XCOM so that we expose the XCOM message cache size and messages, the amount of messages that we keep in memory for the XCOM. XCOM being the Paxos implementations, the Paxos one. Okay, so just to finish this, it's been a lot of fun. It's work at MySQL as an engineer, working at MySQL replication, and this year marks my 10th year with the MySQL replication. It's always never dull. It's a lot of fun doing things, and we can see here that at least for group replication, it's not something that we started thinking, like a year ago, and then we experimented with it, and then we released something out. No, it's something that we have been continuously thinking of, and we have, if you look at this first half of the chart, you can see that a lot of this work was put into 5.7 already, some years ago, like in 3 years ago already, and work continues. It doesn't stop here. We have a lot of feedback, a lot of things to work on group replication, and comes the cloud. This is a natural environment to deploy group applications, so a lot of interesting new ideas and good stuff that we are working on. And the end goal for all of this is to be able to scale out reads, scale out writes through sharding, and continue to execute on this InnoDB cluster story where we utilize one of the best engineering products at MySQL, which is the InnoDB storage engine, together with one of the best and more advanced pieces of technology that we have, which is group replication, and bring this all together to be able to implement a fully, scale out for writes system and scale out for reads system, while at the same time achieving highly available, truly dependable MySQL database service. So to conclude, MySQL 8 was GA like almost a month ago. Lots of different features in it, lots of interesting features in it, especially on replication. But I'm biased. But I encourage you, every one of you, to go and give it a try. Bugs, you can always report through the bug system. We also enjoy hearing good feedback. So don't be shy. We have a lot of blogs from the engineers here. If you are into the gory technical details, I really encourage you to go and read this blog, because it has a very nice, very deep technically, but very nice blogs. So that's all. Thanks for attending. Do we have time for questions, or?
No, it's the last time is a question time.
Okay. So thank you very much.